Hello everyone, we're going to be talking about interpreting scatter plots today for our set of notes. So the first term I would like to define is correlation. And a correlation describes a relationship that's typically between two sets of data. This is a graph that may show the correlation between the data. We'll be looking at graphs. The correlation can also help you analyze trend lines, which we will also be talking, or different types of trends and predictions that you are able to make from those types of trends. There are three types of correlations between our data. So the types of correlations that you will be looking at today, there's going to be a positive correlation. This is where both sets of data values actually increase. So as your x-axis is increasing, the y value is also increasing. As we can look at that example, the dots are going up like kind of in a linear positive line. And then we have our negative correlation. This is one set of data values that increases as the other set decreases. So we see our x value is actually increasing, however, our y value is decreasing. And our dots also form a negative slope of a linear line there. The other one, we're going to have no correlation, which means that there is no relationship between the data sets. As you can see, all the dots are kind of all over the place on the axis, or actually on the graph. So for our first example, we're going to try and identify some correlations that you would expect to see between a pair of data sets. So we are going to take this example, the average temperature in a city and the number of speeding tickets given in the city. So if we think about those two topics, do those actually have a correlation? Well, you'd expect to see no correlation here because the number of speeding tickets has nothing to do with the temperature. Hopefully not. So that's the explanation that you guys will be explaining on these. Our next example, the number of people in an audience and the ticket sales. So hopefully you would actually expect to see a positive correlation here because as the number of people in the audience increases, so the more people that are in the audience, that means that they sold more tickets. The next example is a runner's time and the distance to the finish line. So this is a little bit more difficult to think about, but the runner's time being the faster the runner can run, then the distance to the finish line would be either greater or shorter depending on how quick they are running. So you would expect to see a negative correlation here because as the runner's time is actually increasing, so they're getting faster and faster, then the distance to the finish line is actually getting shorter, right? Because you're running faster to that finish line, so that means you are able to get to that finish line quicker. Now we're going to be looking at scatter plots on an actual graph. So you're going to describe the correlation that's illustrated by the scatter plots here. So if you look at this example, we see our title of our graph is beach visitors. The x-axis represents the average daily temperature, and then the number of visitors is on our y-axis. So what this graph is actually representing, what it seems to be representing, as the average daily temperature actually increases, you see it's going from 80 all the way to 96, then the number of visitors increase that went to the beach. So there's more visitors on the hotter days. So this is a positive correlation between the two data sets because you see our dots as they are both increasing the x and y axis. For example 2, we have our snowboarding competition. We have our years on our x-axis from 2001 to 2007, so our years are increasing. And then our participants, it seems that we are actually having more participants as the years go on. So as the years have passed, the number of participants in the snowboarding competition have increased. So that could be because snowboarding is getting more popular over the years. But however, in this situation, they both are increasing. Therefore, we have a positive correlation between the two data sets because both our x and y are increasing. So you can graph a function on a scatter plot to help show a relationship in the data. So sometimes the function is a straight line, and this line is also called a trend line. You are trying to figure out the trend that's actually happening in your data. So this helps show the correlation between the data sets more clearly, and it can also be helpful when making predictions based on the data. So we are going to look at our scatter plots and the trend lines both together now. So the scatter plot shows a relationship between the total amount of money collected at the concession stand and the total number of tickets sold at a movie theater. So if you see the tickets sold as our X value, the amount made is our concession stands, and this is our concession stand sales with the topic on the top of our graph. Based on this relationship, we want to predict how much money will be collected at the concession stand when $150 tickets have been sold. So I already drew the trend line for you guys. I was trying to hit as many dots as I possibly could. So if you have here, let me show you. So you're trying to draw a line that has about the same number of points above and below it. You may or may not hit all of your data points. That's okay. You're just trying to hit as many points as you can. And on our example here, we were talking about 150 tickets. So we want to find the point on the line whose x value is 150. So on the x value, you see I would like you guys to add the dotted lines to your example, to your trend line. And we see that the corresponding y value then is 750, or approximately. And these are approximations. You see that the x value is counting by 20s, the y value is counting by 100s. And so we want to actually see we are a little bit between the 700 and 800, so we will be making $750. This is a reasonable prediction because you have on how much money we actually collected for selling 150 tickets. Our last example here, you want to draw a trend line. Go ahead and draw a trend line, trying to hit as many dots as you can. Make sure it is a straight line. That is predicting how many wrapping paper rolls need to be sold to raise $500. So I would like you guys to go ahead and try going to the $500, which will be your y-axis. So you're going to go to 500. This is also counting, the y-axis is also counting by $100. So you're going to go up to 500, and then you're going to see how many rolls of wrapping paper were actually sold by putting those little dashes in your trend line. You do need the trend line, trying to go, like I said, a straight line going through as many points as you can in order to predict so that it looks something like this. So I'm doing my dotted lines going to 500, and then I see that we are at if I didn't have this line, you guys, then I really don't know the value of how far I would have to go to the right on my trend line. So once I add this line, it makes it a little bit more accurate. I'm able to see the x-axis is counting by 25s. So I'm a little past 75. However, I'm just going to round it to 75. If you guys want to put like 76, 77, that is our average or our estimated value of how many wrapping paper was sold for $500. Okay, and then there's our complete sentence. So based on the data, about 75, make sure you're saying about 75 wrapping paper rolls is a reasonable prediction of how many rolls need to be sold to raise that $500. All right, you guys have a great day. I will see you in class.